what I find interesting this year is really about coming up with interesting ways to get more out of the architecture that is not just throwing more data at it. And so with a mixed role, which is a mixture of experts, people combine multiple modules like the linear layers later to make a model that is larger, but it doesn't use all the modules during inference at each time step. So it's kind of also smarter. It's not like as brute force as it was before. And or model merging is also another topic. So model merging would be combining multiple models into one model. So there is stochastic weight averaging, for example, to merge a model during the training trajectory. Or there's also um, merging completely different models into one model. Not completely; they have to, of course, have the same weights, but models trained on different data sets into one model. And I feel like this is a theme where people are now focused on really optimizing small in quotation marks, small large language models. And
Right.
I think that is a trend we will see for at least the upcoming months, where people want to get more performance out of LLMs.
Hi, friends, and welcome to this very exciting episode of Leading with Data. Today, I have with me Sebastian Raschka, who did his completed his PhD back in 2017. He was also a guest at our AMA back in December 2016. He's one of the leading researchers, has spent time in academia, and is now a lead educator at Lightning AI. And personally, I've been fascinated by his work, his research, and lately has been writing a lot of very interesting articles on all the developments happening in Gen AI. So I'm looking forward to this discussion, and I'm sure there is so much to learn from him. Sebastian, welcome to the show.
Yeah, thanks so much for the kind invitation. I must say, analytics Vidhya, I've been aware of it at least for like 10 years, I would say, when I was a undergrad or first year in grad school. I think it was founded, and it was one of the big places for data science. So, yeah, I'm honored to be invited on your show today, and I'm excited to chat about everything related to AI, data, large language models, and yeah, everything that's exciting.
Great. So, Sebastian, your journey has been, you've spent quite a bit of time in academia. You're right now leading AI educator at Lightning AI. And in between, you've also spent time in industry, consulting and working. So, in your journey, from your perspective, what were some of the key pivotal moments? And again, you've worked in very different fields, right? So your research was in at the intersection of AI and biotech. So can you elaborate a bit on your journey and how it happened? What were the key decision points for you?
I would say I would say one of the key decisions back then, 2012ish, was to take a class in statistical pattern classification, where it was all focused on Bayesian methods for so not only predictive modeling, but the focus of this class was pattern classification. So it
Mm-hmm.
was essentially something that I found very interesting, because I was working at the time on detecting or predicting the activity of small molecules in a biology context. And yeah, that got
Okay.
me really interested in statistics and machine learning. And I also took, yeah, many follow up classes. I would say that was like the pivotal moment where, yeah, I was really excited about that. I was using R a lot at the time because, yes, statistics and R went hand in hand back then. But it was also
Right.
like when I discovered Python and really got into that. And I think from there, yeah, I just had fun and worked on projects and learned a lot along the way. From like what helped I think was working on these bio problems, because the data was usually very messy and you had to do a lot of coding by hand to just get the data in the right format, and then think about how do you feed it to the machine learning algorithm and so forth. And I think that was basically where I acquired a lot of hands-on experience with messy
Mm-hmm.
data. And yeah, you mentioned I was at the University of Wisconsin-Madison, where I was in academia then after I graduated and got my PhD. And it was an exciting time. I focused on also research, deep learning research more in general, like moving away from biology applications. And yeah, I would say I always liked teaching. Basically, I liked
Mm-hmm.
writing blog posts and teaching. So in academia, it's usually, I would say, 50% is research and
Yeah.
50% is teaching. And eventually, though, I must say I was there for 3 4 years.
Mm-hmm.
I really enjoyed it. I had great colleagues and everything, but at some point you're teaching similar classes every semester, and I was like, I was ready to try something new, like moving from introductory deep learning to more like a research focused
Mm-hmm.
education, like more, let's say, latest trends and or latest developments. And so that's
Mm-hmm.
where I then went to Lightning AI, where we are developing a platform. So we are developing a platform for running experiments. And in addition to that, I'm also producing a lot of educational material at Lightning AI. So yeah, also happy to chat
Mm-hmm.
more about any of these topics later. But just to answer the question, I would say the pivotal moments were really just taking a class, getting excited about the topic, diving in, getting some experience here in academia, and then eventually in industry. Yeah.
Very interesting. And you also wrote a book on Python machine learning, which went on to become one of the best-selling books. When was that in this period?
That was, if I remember correctly, that was either 2014 or 15. It was a long time ago. That was also the time where I was like working with and in machine learning like for 2 to 3 years, and I was like, okay, this is a
Mm-hmm.
great time to write up everything I've
Mm-hmm.
learned. And basically, I wrote this book. So when I write materials, I also selfishly I write things that I would like to read in a way. Like, and so I also wrote that book for me as a kind of like a almost like a notebook, like of things that I learned and things I wanted to share and things I'm excited about. And
Mm-hmm.
yeah, there were a lot of future editions. So we had then. So the first book I ended with implementing a multi-layer perceptron from scratch in
Yeah.
NumPy, because I really like doing from scratch
Mm-hmm.
implementation, because that's, I think, a great way to
Right.
learn. And
Mm-hmm.
I think I used Theano back then just to show that you can also use a framework for that, of course, because from scratch implementations are only, I would say, for educational purposes most of the time. And I think that the second edition was TensorFlow. The third edition was many more chapters also in TensorFlow. And then we moved to PyTorch in 2021, 2022. So that's what I'm also focused on. I'm almost exclusively working in PyTorch these days. I also have a new book coming out in April. That is so I have actually two books in the works. I'm also happy to chat
Oh,
about
wow.
those. But one would be more on the advanced topics that are usually not covered in introductory material. It's not a coding book, but
Mm-hmm.
it's a book explaining, let's say, how to evaluate large language models. What are the different ways to use multiple GPUs for deep learning, and so all these more like advanced
Interesting.
concepts that are usually not
Mm-hmm.
covered in introductory books or introductory courses, because they are slightly of too advanced, I would say, or not too advanced, but um, things I personally, when you design a course for the university or write a
Yeah.
book, you
Mm-hmm.
always have to make sure. I mean, there's a limited time you have per semester,
Right.
and you always have to
Mm-hmm.
be. So there are so many exciting topics, and you have to be always very careful about, okay, which is a topic that is really interesting but is not absolutely necessary, and then you remove that topic, because otherwise you wouldn't have time for all the topics that need to be covered. And so in this
Correct.
book I'm covering kind of like the more intermediate advanced topics. It's called machine learning
Mm-hmm.
Q&AI, sorry. And it's from Q&A, question answer. It's Q&AI, it's a little pun. And
Okay.
the
Mm-hmm.
it has like 30 short chapters where I'm explaining like more intermediate and advanced topics. And in addition to that, that was finished like last summer, but the print version is coming out soon. It is always also, it takes a time from, let's say, finishing a
Yeah.
manuscript to the print version, because there are also editing
Till
steps,
print.
but
Yeah.
it's
Mm-hmm.
coming out soon. And currently I'm excited about a book building a large language model from scratch, which is what I'm currently working on.
Mhm.
And so this is again back to my roots, implementing things from scratch, basically implementing a ChatGPT like LLM from the ground up. So starting with the tokenizer, then implementing the architecture, pre-training, loading also
Mhm.
pre-trained weights. So for that, I currently use GPT-2 because it's like the common denominator. The weights are available. Of course, there are more advanced LLMs, but the goal of this book is really the education of how an LLM works. Because if you once you get the hang of it, all the LLMs like Llama, Mistral, they only have a few tweaks. They are almost the same architecture. So little things like a multi-query attention and these types of things. And yeah, and then I'm also, but I'm not stopping at the pre-training. There's also a step for fine-tuning. So there's fine-tuning for
Mhm.
classification, and there is fine-tuning, supervised instruction fine-tuning, a chapter on that, and then also the
Mhm.
alignment. So with either, I haven't fully decided yet, either with direct preference optimization or RLHF, the classic PPO algorithm.
Mhm.
So yeah, that is one of the last chapters. So I'm still debating which one to use for that. But that will be essentially the full journey from architecture, pre-training, loading pre-trained weights, and fine-tuning, basically, to get something like ChatGPT. Of course, smaller scale, so you will be able to run that on a single GPU. But if you wanted to do, you can also train that longer. It's just not, I would say, economically a good idea to just train a network for the full, I don't know, for the full month, just for fun, because it's expensive.
Mhm.
So I'm also showing how to
Yeah.
load the pre-trained weights, essentially. Yeah.
Interesting. And when is this book coming out?
This might be early 2025 because again, there's like the gap between finishing it and
Right. Mhm.
getting it to print. So currently, the plan is I started last summer. I have almost all the code together. I'm just writing the chapters now. I'm planning because I have other things to do. It's only I work only on this like very early in the morning and relatively late at night. But I'm aiming for one chapter per month. So right now I'm at
Okay.
chapter
Mhm.
4, and this should be finished if things go well by August this year.
Okay.
But
Mhm.
the book won't be out, I think, until 25. But there is it's with Manning, so they have this early access program. So if you want to,
Right.
you can actually already read the chapters 1 to 3. I think they're already uploaded there. So and there will be
Oh,
new
wow.
chapters
So
added.
it's
So
getting
if someone
released
does,
as you're writing them.
yeah, exactly, yeah, yeah. And for the other book,
Okay.
this will be out in April, but there's also a early access version where the whole manuscript is already available because that one is already finished. Yeah.
And that one is also with Manning, or that's with some other
That is with
publisher?
No Starch Press. So that is
Okay.
yeah. And sorry to
Interesting.
talk so much about my books, but it's just something that
No,
was
no,
on
it's
because
fascinating.
it's a Monday when we are recording this, and usually my weekends I'm very yeah, right now I'm really focused on the books on the weekends. So I'm just coming from the weekend, and you just
From the
mentioned
weekend.
books, and I was like, oh, that's something I like to chat about.
No, no,
Yeah.
yeah, yeah. In fact, I would love to spend a bit more time in terms of, one of the things which clearly comes out is, you take a topic and then kind of build it from scratch. You mentioned multiple instances when you've done that and you've shared that in your blog. So, and then you came from or you were studying bio as a subject as well for quite some time, right? So, uh, uh, when you do this approach, right? Uh, there are pros and cons to it, right? So you obviously gain a lot of understanding while you do it, but the con is that you might end up spending a lot of time which may not kind of be really applicable in the industry, or you might have a library where you can kind of directly use and then get some results very quickly, right? So, so what motivates you to kind of do this exercise again and again on different topics, and then what is that driving force when you go through these journeys, or these essentially experiences to build these things from scratch and share it with the
Mm,
world?
mm. I think for me, it's really to get a really good, deep understanding of how things work. Um,
Hmm.
like you said, I would not use this from scratch implementation most of the time for an industry application because it's most of the time not the most efficient one, and like you said, it's
Mhm,
very time consuming, and but it is, I think, still at the same time very valuable. So for example, in this build an LLM from scratch book, in the last chapter, I will also show people how to use existing libraries because
mhm,
this is like for education purposes to implement it from scratch. But in reality, you maybe want to use, let's say, a more optimized library. But then, why doing it at all? I mean, for me, it's first it's fun, but also you can really learn a lot. Like there are questions where about LLMs, for example, where people have a lot of articles explaining, trying to explain a topic like an LLM generates one token at a time, and why is it sometimes not the same token? There's a lot of, let's say, I wouldn't say hand wavy, but a lot of trying to explain something, and it's very abstract, and it's still confusing to people if they just hear the explanation. If you just show it,
mhm,
if you show the different like steps, for example, let's say you have already built the architecture and then you are sampling or trying to generate text, you take one token at a time, you append it to the input, feed it back in, and then you have the decoding strategies where you have either a greedy decoding or with a multinomial distribution or
yeah.
top P sampling and so forth. You can literally see why or how the tokens are sampled and why the LLM generates what it generates. And I think
Mhm,
this is a great way to learn because you can really look into how things work and you can make changes. You know, okay, what if I change this to that? What is going to happen then? You know, it's, I mean, I think it's a great way to learn. And then
it is.
you can also and you can self check yourself. If you implement a GPT architecture, the weights are available. You can load the weights into your architecture, and if your architecture doesn't work, if it produces some weird outputs, you know, okay, there's a bug in my code, and then you can go back and change it until let's say you get it right. And I
Mhm,
think that's also a great learning exercise because you already have in cases of LLMs, you have the solution, you have the weights. And if the same weights, if you plug them into your architecture, they don't work, you know there's something off. And once you have it then implemented, it's also you understand all the code because you wrote it yourself, and then you can make a lot of changes to the code to experiment with it. And if you take someone else's library and make changes to the code, it's usually most of the time you honestly don't know what's happening because it's relatively complicated.
correct.
And yeah, so I think once you have a working implementation you build yourself, it gives you a lot of opportunities to experiment with that, and it's very rewarding, I must say. It can be
Yeah.
frustrating if you implement something and it doesn't work. That's
Mhm.
very sometimes very frustrating, but then once you get it to work, it's one of the best feelings in the world, in my opinion, when it works and it generates the correct output. And yeah, so for me, it's for educational purposes, but also very motivating, actually. Yeah.
And uh, from your experience, what is the right time to do it? So, should you experiment with the actual library before you go on this journey to build it from scratch, or that's usually a good place to start by itself? So, for example, if I'm, let's say, trying to use GPT, should I experiment with it, see some applications, and then go and kind of build it from scratch, or do you think I can already start it from scratch?
I'm. It depends on how much time you have. I mean, implementing
Hmm.
something from scratch is usually a big time commitment. So
Yeah.
with that book, for example, it will guide you through the process, but it will still be a 400 or 500 page book. So if you need to get something done by the next day or by next week,
Then it's a
that's maybe
difficult
not the
one.
ideal time to do the from scratch implementation. And
Hmm.
I would also say it's a good idea in general to maybe not start with a from scratch implementation, so that you at least have a feeling of what you're trying to accomplish, basically, to get some example of the task that you want to accomplish, and also get a feeling of how it works. Like you give this particular data in, this is the output. So to just play around with more like how it works, and then I think building it from scratch is more like a second step. It's like, I would say, almost with driving a car. I think if you tell someone
Consumer and logic.
has never seen a car and you build the car, I mean, makes sense.
Yeah,
But I think it doesn't hurt if you have driven a car before, or you know at least the concept of a car, how it works, before you start building one, right? I think that
right.
is
Yeah.
a good maybe analogy. I also wanted to
And
say,
logic.
like, back to this book. So if you build a car, it's probably not going to be the fastest car. It's like
Mhm.
you have a car so if you have an existing car, it gets you to places, it works, it's something you would then use when you need to go shopping, or you have an errand to run. You use that car that you already have, that you bought from someone, or like from a company that manufactured that car, because it's usually more or less reliable. When you build
Yeah.
your own car, that is mostly because people enjoy it and because they want to learn how a car works. And
Mhm.
so this car, let's say if you start completely from scratch, would probably not be a very fancy car. It would be a very basic car that maybe drives,
Yeah.
but you understand exactly how it works because you build
How
it from
it's
scratch, maybe with an instruction set. And if something breaks, you also know probably how to fix it or what's broken, because you know the parts that went into that car. And I
Yeah.
think that's the analogy where you can use that car, you can drive that car, but it's probably not the best car. So, but then at the same point, the reason is also why you build this car is you get a better understanding. So when your real car is maybe broken, there are maybe some things you can fix there too, maybe doing an oil change, or if something doesn't sound right. I mean, there's a lot of electronics in a car nowadays, but for basic things, you also get a better idea of how that car works. And
Yeah.
then maybe also continuing with this analogy, maybe it's also if you want to get into, let's say, LLM research. In this case, let's say it helps for the car analogy if you have built the car before you, let's say, start designing new cars. Like even if you
Hmm.
join a company like a car company, it it is a good idea if you know how cars work, because you know then better what to, like, what you're talking about and what you want to accomplish at
Yeah.
that company, basically. So in that sense, if you want to get into LLM research, I think it's also a good idea to have at least built a basic LLM, so that then it gives you a better idea of how it's structured, and then you can still learn under the hood how the advanced libraries work. And yeah,
Hmm.
so but I think
And
there's a lot of advantages. Yeah.
correct. And then I think domains where you might need very different data. This could be very very useful, right? So healthcare specifically, for example, could be a very interesting use case
Yeah,
once
so that
you've done
is
this.
yeah, good point. So uh, I think also with transformers, which is like it's an interesting topic, because you have the LLMs that are based on the transformer architecture, like the decoder
Hmm.
part of it. But then, if you look at vision transformers for computer vision for images, um,
Hmm.
it's almost the same concept. I mean, it's kind of like the same concept. You have the same attention mechanism. Instead of tokenizing words into tech, instead of having words that you tokenize into tokens, you have image
Hmm.
patches that you patch up the image into smaller chunks, and then you also convert them into tokens. And these tokens, they are basically the same in both cases. So if you learn about LLMs in language, that also will help you to understand vision transformers, for example. But then also what you, I think, wanted to get at is in medical applications you have different, let's say, domain specific texts. Is that what you meant? Or
Correct. Yeah. Yeah.
yeah, so if you have your own LLM, that also, yeah, if you want to work on something that is currently not supported, if you have private data or something like that, your own LLM would also help. But there, I must say, fairly that so just there, I would say you can also use an existing library, because if you use an existing library, you don't have to use the pre-trained weights. You can use
Correct.
also random weights. So in that case,
Yeah.
I would say the from scratch might not be solving that problem, but it still helps you understand how LLMs work in case you want to optimize or change things, or in general study LLMs, get a better feeling of how they work and so forth. So yeah.
Interesting. And while you are creating these, pieces of content, be it for your book or for your blog, have you incorporated generative AI assistance in the process, or you're still, because it's very technical, it's not
Hmm.
in your workflows yet?
Honestly, yeah, I do use LLMs also now to help me with the writing, but it's mostly for
Hmm.
fixing errors. It's like
Okay.
sometimes it depends. So sometimes I can write a whole article without using anything, so I would just write it myself. But sometimes, I don't know, it depends on the day. Sometimes I have something, it just doesn't sound right. I don't know, I have written this and it's like, somehow I don't like how it sounds, and somehow I need some help here. And then I would just use an LLM and say, can you rephrase this sentence? And sometimes I like it better, sometimes I like it worse, but I do that sometimes to just help me continue, like that I don't get stuck at a certain passage that I don't like. Or sometimes I use it
Mhm.
also. I mean, there are other tools for that, but I sometimes use it for grammar correction because I'm not a native
Yeah.
speaker. So sometimes I say correct grammar as a prompt and then put in my text, and then it also helps. I don't always like the outputs, but what's nice is you don't have to take them, right? I don't fully automate anything, so I look at this and like, okay, this I
Mhm.
like and this I don't like, and then I piece it together. But I would say
Mhm.
I don't use it extensively, because usually I have a pretty clear idea what I want to write about. So
Mhm.
that's, I think, is also important. I think if you want to create or write something, you have to be interested in the topic, right? And if you're already interested in the
Of course.
topic
Yeah.
and you know what you write about, it usually flows out of you automatically. And then, but then the
Correct.
LLM can be helpful to polish it up, basically, I would say. Yeah.
Mhm. Yeah. Uh, the other part which I would love to, delve deeper on was this, academia versus industry, and you mentioned briefly your reason why you moved from academia to industry. But let's say from a perspective of a postgraduate student who is, let's say, now coming out and has already done some work in data science. What would be the pros and cons, or what sort of career would they see if they were to, let's say, go in academia? What would or what should be their framework to think about, let's say, spending time in academia versus spending time in industry research and pursuing their career in the industry?
That is interesting question. I'm always a bit hesitant about career advice because
Hmm.
I would say I don't want to give wrong advice. I just wanted to say that upfront. This don't take this maybe too literally. Um,
Yeah.
and also, I only have two data points here because I've only been in academia once and only in industry once. So I only
Sure.
have these two perspectives, like only one example from each perspective. But I would say, yeah, in
Yeah.
academia, what I liked was like you are free to design your own research agenda and work on research projects. And I also
Hmm.
really like working with students. It's very rewarding. So you build your team and you work with your team on a really cool research project. I would say the only thing there is the limitation in academia is usually the compared to industry, the compute access. I mean, this is also depends on which university, and also it changes. Some
Hmm.
universities have newer clusters, some need to update their clusters, but in general, in industry, there's usually more access to, let's say, more resources for compute, where it is making it a bit easier to run nowadays larger experiments. um,
Hmm.
in academia, then the advantage now is you can freely publish what you write. So you design your
Yeah.
research and you publish that research. The only thing is, of course, it's a good thing, but it can be frustrating sometimes because that's how your success is measured. And yeah, conferences are very competitive these days. So there is, I think, at Europe's and so forth, a 20% acceptance rate, 20 something percent. And so on average, I would say, I mean, of course, it depends on how good your paper is, but maybe let's say only every fifth paper gets accepted, right? If it's 20%,
Hmm.
and you submit 5 times, one time it gets accepted, 4 times it gets rejected. And that can also be frustrating, right? So in that sense,
Yeah.
if publishing is very important and then sometimes it's not accepted because of an acceptance rate, this can be frustrating. So of course there are cases where a paper doesn't get accepted because it's wrong, and then I think it shouldn't be, if it has errors, it shouldn't
Of
be
course.
accepted.
Yeah.
But there are also a lot of papers that are technically correct, that have maybe not the biggest impact, but the paper is correct, there is some interesting insight in there, and they don't get published because of quotas, and that can be frustrating. So that is one thing I would say that I did not like that much about academia, where
Hmm.
sometimes you had something was correct, but I don't know, the reviewer didn't like a certain organization of the paper, or minor things that get a paper, let's say, rejected, or in general, like I don't know, it's always a somehow a noisy process. And
Mhm.
so that could be one thing where I would say that's a downside, that the process is currently noisy. But otherwise, I think academia is a great place to be, but also so is industry. That's the reason also why I'm in industry, right? So, and for me, it's right now I have great colleagues, and the difference
Mhm.
is, I would say, I work with people in a team who know more than I do, so which is great. So not universally, but there are areas where someone always knows something more than you do. In academia, you are usually, if you have a lab, students are extremely smart and dedicated, but you're basically more like taking a supervising role. Whereas in an
Mhm.
industry, it also depends, but you have people who are more specialized in certain things. One person is, let's say, specialized more in server stuff. One is fully specialized in multi GPU stuff, and one person is really specialized in a certain research area, and it all comes together, and it's you're working more as a team there. I would say. I mean, in academia that's true
Yeah.
too, but in academia, I would say many people they have more the research background rather than the computing background, which is also
Correct.
valuable. But
Mhm.
I think, that's one difference I noticed so far. So I
Mhm.
think, computing wise, if you don't have a research position in industry, it is a it is actually quite cool if you have a lot of colleagues who know a lot of things can pick up there and learn from. And I think this is maybe also
Mhm.
particularly true because I spent such a long time in academia, where my background is more research, but then I joined a team where a lot of people are more computational rather, let's say, than research focused. And for me, it's great, basically. So yeah,
Yeah.
and I
And
I learn a
and
lot,
uh,
and
and
yeah. So
yeah. I'm presuming when you made this transition, you would have ended up spending a lot of time focusing on engineering and then a lot of these practical challenges which you might have come across in building the platform. Is that?
Yeah, so I learned a lot, like from the platform work, basically. But also, what's nice is we mentioned the challenges and everything. But so the goal of the platform is also to remove these challenges. So the platform we built, Lightning AI Studios, is basically,
Mm-hmm.
you can think of it as your own computer. You have
Mm-hmm.
access to Visual Studio Code, Jupyter, and so forth, but it's in the cloud. So
Okay.
you don't have to. So basically, if you create a repository on GitHub, um,
Mm-hmm.
so you have the code up there. But if you share that code, let's say it's a research project, then it's really up to the person who downloads it to install all the requirements and get it to work. And this is
Mm-hmm.
usually very challenging if you work with more advanced methods. For example, I was participating in the NeurIPS LLM efficiency challenge last year, which was a
Mm-hmm.
challenge to train one LLM on one GPU for one day. And this
Yeah.
was a very exciting workshop.
That.
And it was so there was a specific way you had to submit the submissions so that it gets ranked also in the leaderboard and so forth. And then also
Mm-hmm.
the organizers had to download the submissions and run them. And they were like Docker containers and was a bit tricky and so forth. And so basically you have to, when you download it, install all the requirements and so forth. And for research code or any project, it can be a lot of hassle. And so with a
Mm-hmm.
platform, it's essentially you have all the code there, but you can also run it. You can run it on one GPU and multiple GPUs. You have a Visual Studio Code interface. You can use Jupyter Notebook, so you never have to leave the environment. So it's essentially, can think maybe of it like as Google Colab, but
Yeah.
Google Colab with multiple GPU support and Visual Studio
Mm-hmm.
Code support. And you can flexibly switch the machines. You never have to. So in Google Colab, if you switch a machine, your data is gone. You have to re-upload it and so forth. And this is like
Mm-hmm.
persistent. So with that, so we worked a lot on
Interesting.
building this platform, but now that we have this platform, there's not much hassle anymore. Actually, no hassle. So when I work on my research projects, I just use
Got
that
it.
now, and I can just switch machines. I don't once it's installed, like my Python requirements, it stays there. I never have to install it again. I can share it with my colleagues. We can collaborate on
Mm-hmm.
that, and it was a lot of work getting it to work. It took like 2 to 3 years, but now that's there, it's actually really fun to work on research again. So yeah.
Interesting. And then this platform enables you to essentially move the codes into production as well, or this is mainly for the
Um,
training and
no,
building
you can do
the
anything.
model.
You can really think of it as your own computer, but it's in the cloud. But so on your own computer, you can use all the tools. So there's no
Hmm.
so there it's Visual Studio Code and Jupyter, and there are also plugins. But you
Got
can
it.
also develop an app that serves you an API endpoint for an application. So for the
Hmm.
LLM efficiency challenge, I did not work on it myself, but my a colleague. So the leaderboard that was evaluating the submissions was actually built
Hmm.
on Studios. So that was in a backend a
Interesting.
studio running and connecting to
Hmm.
Discord, and then posting the
Okay.
results on so evaluating the LLM and then posting the results back to Discord. So it was essentially also a studio. So it was an application built with a studio. So personally, I don't do much production work in terms of building applications. I'm more like a research person, but you can do anything with that basically. So you're not restricted only to training.
Got it. Got it. Very interesting. And these models, or let's say if I go ahead and deploy, would I need to sign up on Lightning AI, or I could use them through AWS and some of these cloud providers?
So how it works currently is you would have to make an account. There are 30 free or 20 or 30 free credits where one
Hmm.
credit is $1 for GPU usage. I think it's even per month, but so you can try it out for free.
Hmm.
It's like Google Colab where you can use it for free, but if you want more compute, of course, yeah,
Right.
GPUs are not
You'll
free. You
need
would
to
pay,
pay,
but
of course. Of
you
course.
can.
Yeah.
And to your question, you can, as far as I know, connect your AWS account. So you can bring your own AWS account if you already have one, so you can use the credits from there. And we will also
Hmm.
enable where you can bring other cloud providers accounts in there. So and we will also we are currently working on enabling connecting your own cluster. So we already have that
Hmm.
with a certain number of bigger. So we work with a lot of companies, and with some bigger companies we already enabled that. But we will also roll that out for more people where if you are in university, you have a GPU cluster, you don't, let's say, want to use AWS accounts or any cloud credits, you can actually connect your own cluster. Because really the cool thing about the platform is the interface. So if you would see it, it's essentially think of it like Visual Studio Code, Jupyter, and all the. It's like how you would code on your own computer, except you can flexibly switch the machine. And what's actually nice about that, I should maybe briefly mention that because yeah, you can use multiple GPUs on other machines on AWS as well. But when I used
Hmm.
AWS, usually how it worked was I was requesting a machine. So that was when I was a
Yeah.
student, for example, I was requesting a machine, and then I spin up the machine, have to install everything. Of course, there are containers, so you maybe start from that. You get everything to work, get your data up there, but then you are still finding bugs or trying to work um, to get the code to work because the reason you're using this is because locally you only had a CPU, you're switching to the GPU, and now you have to debug the code for the GPU. And the whole time
Hmm.
the machine is running, you're paying for that, right? So you're paying sometimes A100 machine, which is like $30 an hour, just to do basic
Yeah.
debugging, basically. Or if your experiment is finished, you are plotting results there, and it's kind of like a waste of money to use an expensive machine not to run the code, basically. And in the platform, what you can do is you can switch between the accelerator. You can use a CPU just to make sure your code is all running and let's say looks okay. Switch to
Interesting.
maybe one
Hmm.
GPU, run it, and then once you're ready, you just switch to eight GPUs and then run it again. So you can,
Yeah.
and then you can switch back. You can switch back and forth. It takes like a minute, and all your files, all your data is there. So it's kind of like saving you money by not wasting, let's say, precious time on the expensive GPUs. You only use them when you actually need them, basically. Yeah.
Very interesting. And while you're doing all of this on the platform, essentially, it is obviously convenient, and then you're getting all of these things at one place instead of kind of moving in different places. That's essentially
Yeah,
the
so it's
key
basically the goal
proposition.
is that you never so once you so let's say you start a new studio. I have my let's say my book project. I have my book there. I install some requirements. So for example, in chapter 2, I'm explaining how to build a tokenizer, but we are using then also tick token from OpenAI because it's a faster
Hmm.
tokenizer. So we explain how to build a tokenizer, but then using that tick token just for speed during training. And I would install tick token as a dependency in Python, like pip install and so forth. And
Yeah.
but you only have to do it once. When you change the GPU, for example, then your whole environment is on that new machine on GPU. So you basically don't even think about different machines. It's basically the same thing where you connect different GPUs to it, basically. So in that sense, you don't have to reinstall anything. You don't have to transfer your data. It's all there. It's as if you have your own computer and you connect a new GPU to that computer, basically. Yeah.
Interesting. And shifting the topic slightly, right? Last time, and this
Sure.
was although some time back, this is December 16 when we last discussed. You had mentioned that you use Twitter feed as your first source of information in terms of what's happening in the domain, and that helped you kind of see what's happening. Uh, how does your research workflow look today, and what does a typical day or typical week look for
Oh,
you
a typical day.
now?
Yeah, typical day is usually I wake up very early, like at usually at 5 a.m. in the morning, and then I write on my book
Mhm.
for like 2 hours. Then I usually
Okay.
have breakfast and a tea, and yeah, chill a bit, and then my workday starts. And
Hmm.
but in between, I also occasionally check Twitter just to make. So for me, it's I use it only for technical purposes instead of. So I'm not posting any personal things or something. It's for me more
Yeah.
like staying on top of what's currently happening in AI research. But Twitter is only one
Yeah.
of the places. I was a moderator at Archive for the machine learning
Hmm.
category, and that built my habit also to scan the releases on Archive. Because
Releases.
as a
Okay.
moderator, you
Hmm.
had to make sure there's nothing weird in there, so you had to fix that
Yeah.
then. And in this case, I like to scan through the articles, and I usually bookmark a lot of articles, and then in the evening well, on the weekends, I usually also when I have my newsletter once a month, I do also summarize most of the papers. So I usually pick 1 or 2 papers a week that I actually
Hmm.
read in detail, and then I would
Hmm.
also write summaries. But yeah, usually it's a mix between scanning archive, like the releases, the titles, and using
Hmm.
Twitter, because yeah, archive gives you just more like the raw list, and Twitter also sometimes gives you interesting discussions because sometimes people have an interesting observation, for example, that you because you
Right.
don't have time to read all the papers. There are like 100 or 200 papers each day. I don't even have time many days to read even one paper. So it's like you have to be very selective, and Twitter helps a bit with filtering for articles that are really there's something interesting about them, otherwise they wouldn't be shared, basically. Yeah, but then of course it's always also a challenge not to get distracted. So, and also I must say I keep up with a certain number of things, but by no means I'm on top of everything. There's just so much happening that yeah, you can't. So for me, it's what's important is really picking things you are excited about, because that's I
Hmm.
think also important. Otherwise um, I wouldn't enjoy what I would do if it wouldn't be fun. So, I mean, fun is there's a fun is on a grand. I mean, I enjoy reading papers, but of course, if you think about other activities, I also like skiing. Skiing is, for example, more fun than reading a paper, but reading a paper gives me a certain amount of confidence or pleasure or something like that. There's something about it where I enjoy doing that, and I think in general, I think it's important to pick things that if you can pick things topics that you find interesting because in the long run that is I think how to get become successful is to build on that. So you have to be consistent and because yeah you can't really I think become an expert in a week or a month or a year. It takes many years, and in order to I don't know put in the hours because it's a lot of hours you will have to spend, you have to
Yeah.
make sure it's something you are interested in. Otherwise you would drop it maybe after a few weeks or months, and then you have to start over again. So yeah.
Right. Right. That is true. And from your perspective, right, and then largely in terms of the research which you see happening today, what are some of the key breakthroughs which you think would come across or which would happen, let's say, in the next 12 to 18 months time frame, and then which
Mhm.
would kind of be exciting? So what are some of the trends or areas you're kind of looking out
Mm.
for in that sense?
Oh, that's an interesting question. I would say my field of view is very focused on LLMs. So at the moment, um, I follow computer vision, but really most of the things I know very specific to LLMs. So I'm just saying there might be interesting things happening in computer vision too. But from an LLM perspective, I think last year we have seen a lot of open source breakthroughs, like starting with
Yeah,
Llama and then Llama 2, and then all the
to
other models that came later. And
outcome
we have
and like,
yeah, we have seen like people went from 7 billion parameters, Llama 2, the smallest one, to 70 billion. But then
yeah,
70 billion, that almost gets never used in the new exciting projects or research. All the leaderboard models are mostly the 7 billion models right now.
right,
And so last year it was basically towards the end of the year, I think, towards optimizing these. So we had like Mistral, and then Mixtral, which is the MOE. It's like what I
right,
find
yeah,
interesting this year is really about coming up with interesting ways to get more out of the architecture that is not just throwing more data at it. And so
hmm,
with a Mixtral, which is a mixture of experts, people combine multiple modules like the linear layers later to make a model that is larger, but it doesn't use all the modules during inference at each time step. So it's kind of also smarter. It's not like as brute force as it was before. And
hmm,
or model merging is also another topic. So model merging would be combining multiple models into one model. So there is stochastic weight averaging, for example, to merge a model during the training trajectory. Or there's also um, merging completely different models into one model. Not completely; they have to, of course, have the same weights, but models trained on different data sets into one model. And I feel like this is a theme where people are now focused on really optimizing small. I mean, small in quotation marks, small large
yeah,
language models. And
right,
I think that is a trend we will see for at least the upcoming months, where people want to get more performance out of LLMs. And of course, you can also do a lot from the dataset perspective. So the Microsoft Phi model, I think it's just let's say 2 point something billion parameters. I'm not sure. I think 2.8,
right, yeah,
and
hmm,
even smaller. And they got really great performance by focusing on dataset quality, for example. So I think there are so many different directions. People are really optimizing the small models, and I think this is also partly motivated by the fact that you can run them on a single GPU, and you can run them in a reasonable time. So you can get the results maybe in a few months rather than a few years. But once I think people have figured that out, that can also be used to scale it to larger models. I think the same
yeah,
learnings, the same techniques. But I think, yeah, right now I think the trend will be still exploring ways to optimize smaller LLMs that is
hmm.
like adding some novelty, or not. I mean, mixture of experts are not novel ideas, but novel ideas
Up to
in the context
them
of
to
LLMs.
solve these.
Yeah, yeah, and I think there will. I mean, things we don't know yet, but I think there will be also techniques that are not already existing and applied to LLMs. There will be some other things. Hard to say what it will be because it's not there yet. But I think there will be quite interesting things happening
And
in the
have you
realm of small
tried with
LLMs.
yeah, Mamba is one of the things which is coming up. Have you tried using them, and how's your
I have
experience?
not. So yeah, Mamba would be. I think it's a selective state space model, right?
Correct. Yeah.
So I read a bit about structured state space models and selective state space models. So Hyena, I think, was a structured one, and it sounds interesting. So I think the idea is essentially you have something that is not a transformer. It's more similar, I would say. I mean, it's its own thing, but I would say it's more similar to an RNN, where you have more like not the quadratic but linear cost during inference. The thing is, I think with Hyena, I think there's no input dependence. And I think when I remember correctly from Mamba, they solved that. They have some input dependence, which you need in language processing, so that the order matters and the input
Yeah.
influences the output, like the order of that. And it looked very promising. I think there was also RWKV, which is like a different approach, RNN based approach. So
Mhm.
there are these different ways people try to develop alternatives for transformer based large language models. I do think they are mostly on the smaller scale right now, just because I think the focus is efficiency. So it makes sense to have them smaller. I don't know on the large scale how competitive they will be with the largest
Yeah.
or cutting edge LLMs yet. Because I think the one thing to keep in mind is these are emerging and they are really competitive and really good, but it doesn't mean that transformers are standing still. They will also be improved. So it's like,
Of course.
but I think it's great that people are working on these alternatives because yeah, I think that's how innovation happens, because people try different ideas and see how far they go with that, and I think this is great. uh, it just, I think, for something like a chat gpt like scale, I don't know if they will be that good, because I think right now they are more focused on the efficiency rather than the qualitative outputs. I mean, qualitative outputs are, I think, is almost as good as the current edge 7 billion models. But I, I really don't know whether these will be taking over transformers. It remains to be seen. I think I find them interesting, but we will see how far they can push these architectures. Yep.
Sure. Just one last question, Sebastian. Uh, any specific problem which you would love seeing solved using LLMs, and then you would love to see great impact by solving this problem using some of these AI techniques?
I think, to be honest with you, a lot of people talk about AGI. I don't know if we need AGI, so I don't think this is a problem I would be personally interested in. I mean,
Hmm.
I think AGI maybe it would help with developing better algorithms, but I feel like applications I have a use for are almost all kind of solved. What I care about is, like language translation, grammar detection, maybe improving
Hmm.
my writing. And I don't really need an LLM that can take over my writing because then I do like doing my writing myself. So in that
Hmm.
case, I think right now the only thing, so what I do like is asking it questions sometimes also, where uh, it is something so for coding especially, like I have an implementation and there's a bug, and like, hey, can you help me find that bug? And sometimes it actually, as a companion, it can help with identifying that. And I would just like to see that becoming better. But I must say, on that trajectory, if we take the last few years, and we had a certain number of progress from GPT-3 to ChatGPT 3.5 and then GPT-4, if that continues, I'm quite happy. And the same then with my open source LLMs, if we can get them to that state where we can also run them on our own devices and get that good results. I think um, I think that would be great. Right now, a lot of people focus on building the general purpose chatbots, where you have an LLM that can answer questions and do all these types of things. But I think thinking also more about specialization, I think there are a lot of interesting applications we can already solve today by just having the data. I think the data is more like the bottleneck, but usually you don't necessarily always need a general purpose model. I think there are lots of probably in medicine, lots of problems that can be solved also with specialized models, and I think that will be interesting to see how people can adapt. Right now, I think the bottleneck is really that these architectures are very compute intensive and also data hungry. So I think what I would like to see is maybe achieving good customizability with less data. That would be one thing, and so we'll see. But I think right now, if you look at small open source LLMs, and I think this just I mean, I would say it just started. People really just started last year to get really, really serious about it. If you give it a few more years, I think it will go a long way. So I think we are all on a good trajectory there with seeing a lot of improvements. So I don't think necessarily we will see something totally different this year, like something that
Mm-hmm.
is better and has not never been seen before, because I don't think that happens so quickly. Even with
Yeah,
GPT, it was, I think the first architecture was out there in 2018. It takes many years to get there. Even
true
if you
that.
had even if you had an architecture that would be better, it would take even a year to train it, right? So I think I wouldn't
Yeah,
expect something groundbreaking this year, but we can expect gradual improvement. And I'm actually quite
improvement.
excited about that because things work well. And if
Mm-hmm.
we continue working on these things as we do, I think there is exciting things ahead.
Great. Thanks a lot, Sebastian, for sharing those insights and sharing your journey. I think ton of learnings and then very interesting perspective in terms of some of the areas you're working on, and look forward to hearing back from you sometime in future. Thanks a lot for your
Yeah, that
time.
was exciting. Yeah, thanks so much for the invitation, and I had a great time. And yeah, maybe we can chat again sometime in the future. So yeah, thanks.
Thank you. Thank you.